Okay, let's go ahead to the first lecture, tropical number system. Unlike the usual summation and multiplication, in the tropical world, the summation and multiplication is a little quite different. So let T is defined by extended real number valued system, which means that R union minus infinite, and define a tropical sum check A, B in T. Define the tropical sum is defined by maximum between two numbers, and multiplication is the natural addition, as you know. Then we call this a tropical number system. Okay, that is the definition. But the notation is by others, the notation is a slight different. Some mathematicians use the scale in plus with scale, and instead of circle, instead of product notation, just dot point. And another textbook uses the question mark. That is a tropical sum, and that is tropical multiplication. In this Tübingen University textbook uses this notation. But anyway, we should check that this system is whether the system is well defined. That is very, very important. If it is not well defined, it is not useless. To check the well-definedness, one standard basis is to check identity or inverse, existence of the identity and inverse, each summation, each operation. But in case of the tropical multiplication, it's just addition, as we know. That is okay. But we should think about in case of a tropical summation, whether the identity or inverse exist. Or other properties are commutative law, associativity, and distribution law, and so on, to check this system, to verify, to check the system is well works. Okay, check the identity. For example, what is the identity? In case of group system, if operation is given, if this relation holds every lives in A in G, we call E an identity of E. Okay, let's take this, apply this property to a tropical operation. That is that here. In fact, a tropical summation naturally satisfies the commutative law. Okay, so we should check one of them, which means that for all A, in that case, A is T, and E also in T. Okay, then we should find this result for every A in T. If we plot the graph, horizontal graph, if A is given here, and to satisfy this equation, identity E should this part. Okay, then whether A and when comparing to A to E, A is maximum. But note that for every tropical number that holds. So if A is here, then does not hold. This part does not hold. So the E should move the left. Then okay. But A also can move here. So to hold this equation, we should extend the extended real number valued system. As I said, Y that is essential part to consist of tropical number system. To hold this equation, the result is the only way to hold this equation. E is a minus infinite. So whenever A comes to here, the result is always A. Okay. So identity of a tropical number system is minus infinite. Of course, as I said, tropical multiplication is just natural user addition. So this is trivially exists the identity and inverse element. Interestingly, when we investigate the inverse element of tropical sum, I only focus on the tropical sum. For example, let's see this equation. When we solve the tropical summation equation here, and when comparing to the linear equation, as you know, okay, that means that the definition is here. But this equation is not the equation, because if x is greater than equal to 3, by definition, that result is 3. Otherwise, that is, that is x. And in that case, that is 3. Whenever the x comes, the result does not 1. So in this case, does not a solution. So this is not a equation. In this, that means that the inverse of tropical multiplication does not exist. Why? If we solve this linear equation, the reason why we can obtain the solution is that we can adding an inverse element or sum, use a sum, due to the existence of the inverse element. This guy's to be 0. 0 means that identity of the user sum. So we can obtain the solution. If the inverse exists, we can obtain the solution, this solution, but that in that case, the inverse in the tropical number system does not exist in general. That is important part of the tropical tropical system. Okay, inverse element does not exist. Okay, as I said, a tropical number system commutative law is obviously hold maximum A between A and B and maximum between B and A is the same. Okay, and associative, in case of associativity law, associativity law, tropical sum A plus tropical sum B C is equal to this here. For every tropical number system A, B, C, T. That is easy to prove because we by definition we can give an order. So without loss of generality, let A, B, C, we can obtain the result of associative law in a tropical number system. Finally, distribution law also satisfies, which means that in that case, tropical multiplication and tropical sum, okay, that is here. So okay, yeah. So so the tropical number system, except for the inverse, quite a reasonable number system. Okay, the next theme is the algebraic structure of a tropical number system. Then the next question is that we can understand T is an algebraically algebraical, we can understand the tropical number system as an algebraical view. As is so, R is a field, integer is a ring, like this. What is the algebraically tropical number? What is the tropical number in an algebraic sense? In fact, T, we can see a T of field. Okay, that is a field structure. But the special name we can define, we'll define a special, very, very special but unfamiliar abstract structure, that is hyperfield. Hyperfield. What is a hyperfield? Let's go there. A hyperfield consists of 5 tuples. K, that is a field. Here, 0, 1. Because the notation of a hyperfield, this and this, but the reason is why some author use the tropical addition and multiplication like this, okay? Then, that is very strange set. First, that is K binary operation, but spew out power set but empty set. That is power set but empty subset. Power set of K, okay, but not empty subset. And that is also function, binary function, right here. Then the first condition, just enumeration of the definition, so it's a boring. K star means the K, but 0 is a abelian group. And for all K lives in K, that is 0. But note that when comparing the tropical summation, where it is here, that is a function. That is okay. That is not quite different. But note that that is here, because this part is made us this crazy. But I will introduce the another part of this part. For any x, y, z in K, that is distribution law. Here, That, and let's see this here. That is the distribution law as you know, but there when you compute, that's it. Compute this and these guys and these guys, the result is a subset, power set of K. Okay? Remind this property. And this forms a commutative definition hypergroup. What is a commutative hypergroup? The first, that is within the addition, within the addition, power set minus P. First, that holds associativity law. That means that you see, but when we compare, when we think about the definition of this here, we should check that that is well definedness of the tropic well definedness of this operation, because x sum y lives in P subset in K, okay? But why then how we add this result and Z? That leaves, that is not a K, that is just P, that is P star K, the power set of the power set minus the empty subset, okay? That is a power set, that is a K, a set K. So to solve this problem, the following or the additional definition will be required. So if A lives in K, where and the situation is here, define that is a subset of, or anyway, power set of K, okay? And this is that. Oh. Here. Take A and K, X, okay? That is defined union of A plus X. That is well defined, okay? And we can show this case. Both of the power set, both are power set. In that case, that is defined as here. That is, in this reason, the operation, associative operation, is well defined. Okay, we are going to what is the definition of a commutative hypergroup? A, B is commutative law. It's okay. For every in K. That is also every in X, Y, G in K. And 0 is an additive identity. That means that. But the result should be, okay, power subset. Because when it comes definition, okay, the result comes to a set, power subset form. And inverse, in that case, you can define an inverse. But as I said, the inverse, normal way, inverse does not exist. Okay? But in a hyperfield system, we can define an inverse element. In that case, identity subset, power subset is the last property is so-called reversibility. That means that if, okay, X, Y, if X is this power set, is an element Y plus G, if and only if, let's say, lives in here. Okay, that is definition of a hyperfield. As I said, want to say that tropical number system is a hyperfield, but the notation, what is a 5 tuple, what is a 5 tuple, as I said, that is T. Okay, T is K, and okay, I set it here. That corresponds to user sum, and 0 corresponds to minus infinite. As I said, the identity of the tropical sum, and multiplication is a 0, and the strange part of this here, where Ty is defined by the result. The two, we can take two x, y, and t, Okay, T to T, the result is power subset of T. Okay, so the result comes to set. The set consists of closed interval consists of here. Oh, that is very strange. But tropical number system, when we view a tropical number system as a field structure, especially hyperfield structure, we can see this. And that is the Tübingen University tropical geometry, or my Instagram lecture 301 lecture. Why this is a hyperfield, and why this part is related to a tropical geometry. Okay, the next part is the Archimedean property. We'll recall that what is an Archimedean property, so-called AP. That is most important properties, one of the most important properties in the real number system. For any, we can take for any real number in X, take a real number in X, then there exists an integer and positive integer, such that means that X is given by multiplying n that is greater than y. So if x, y is given by multiplying a proper integer, we can take the inequality. That is Archimedean property. And its corollary, if we change x is epsilon and m is a large n, y is a 1, for any epsilon is given, there exists an integer n such that 1 over n is smaller than epsilon. That part is most important to real analysis to verify the epsilon delta law, n epsilon law in a beginner for real analysis. The next question is here. This property, these properties, this property hold in a tropical number system. That means that every multiplication and summation, as we know, is changed by tropical summation and multiplication. That means that when you consider based on the original property of Archimedean property, nx means that we can understand, because n is an integer, positive integer, we understand mx means that like this, okay? So in a tropical number system, this means okay. So in the tropical number system, so mx is defined like this. So in a tropical version, for any x lives in T, there exists a positive integer such that this equation is about y. I missed the two variable. Okay, this part, if this stars hold Archimedean properties satisfy. But as expected, when we consider the definition of a tropical sum, this does not hold. That is trivial. I said when we know the definition of tropical addition. For example, when you consider 2, what is 2x? In a tropical world, 2x means I don't like to solve the equation. This here, okay, x plus x. As I said, that means that take max x and between x and x. That is just x. So when we obtain the result, we can obtain the following result. That is important. We call idempotent. So tropical summation has a proper nice, but not nice. Particular property, so idempotent, which means that when we take n times of summation, so first let's 3 times first see the 3 times of the summation. That is also x, because when as I said, associative law satisfies. Okay, take this part, then that is x plus x and x, and that is again this here. But max between x and x is still x, so we can we can obtain x. So mx is also x. So x cannot greater even if the summation and summation is repeats. So if x is y given, even if we cannot many times repeat the result, the summation, we can the inequality does not change. Okay. So on the tropical number system, Archimedean property does not hold. Unlike a real number system.